Okay, so this video is going to be the instructions for the Properties of Waves Virtual Lab. So you should have this handout right here. The first, it says going to click on the link for Waves on a String. I've already included that as an attachment. We're going to be using two different virtual labs to do this handout. So the first one you're going to go to, and you're going to follow the directions. Now you did this same simulation on Friday, I believe, so you should be familiar with it, and you're going to follow the directions. When you get to number 4, it's going to tell you to put in certain amplitudes and certain frequencies and measure the wavelength. Now we did the same thing the other day. We're talking about that. First, let's look at I want to go over just a few things with you. You know, if we have a longitudinal wave like the one on top, the orange one, and the blue is a transverse wave. See the difference? You know, sound waves are longitudinal waves. If you notice, the wavelength of a longitudinal wave is between, you know, the distance between compressions, and the wavelength of a transverse wave is measured from the crest to crest or trough to trough, and the wavelength is going to be in meters, and the amplitude is the height of the wave from the rest position. Now I can change all these. Look what happens if I change the amplitude. If I go down, makes the amplitude smaller, that would be less energy in a wave. If I go up, the waves get higher. You know, that would be more energy. Think about like a tsunami compared to a regular ocean wave. All right, so what happens about the frequency though? If I increase the frequency, if you notice, I shorten the wavelength. So if I increase the frequency, the wavelength decreases, because frequency is the amount of waves that pass through a certain point in 1 second. So you have the higher frequency, mean the more wavelengths are passing through there, so the wavelengths would have to be shorter. If I decrease the frequency, the wavelength increases, and there's less energy in that wave. So the higher the frequency, the higher the energy, but you also got to remember the shorter the wavelength is, the higher the energy. So those are just some terms that we went over and I've talked about a lot in this unit. So once you get to this waves on a string, and it's going to ask you to put in different amplitudes and frequencies, so you got your arrows there, you can do that. It's going to ask you to measure between those things. Now you can move this ruler. I wasn't aware of this the other day when I did that, but if I put this, whatever values it wants me to put in, it tells you to pause it. If I pause it, I can measure from the top of the wave, and usually where it starts right here is like the top, you know, of the wave or close to it, you know, as long as you get something close. And I want to measure it, say like this would be somewhere around 4.2, and that's centimeters. I want to convert that to meters, because that's what I need is meters. So if I go back, if I put in whatever wavelength I put in centimeters, I want to go from centimeters to meters. I would, you know, whatever it is, when you put these in and you get a certain number in centimeters, divide it by 100, and that will give you your meters. That's what I want in that column. It asks you to do that on a few different ones. You'll go through and answer these questions. When you get to here, they'll tell you to put some other ones, you know, leaving all your amplitudes the same, change your frequencies. Again, measure your wavelength and put it in meters. Divide by 100 from centimeters, will give you meters. Put all your values in for meters. And then you're just going to keep on going through. When you get to simulation B, it's going to be a different simulation, and I'll have an attachment on there. It's going to tell you to choose sound. You're just going to follow these directions here. It's pretty straightforward. You're going to follow these directions. And then when you get down here, it says change the simulation to water, and I'll show you in a minute what that means. Change the view to side view. Answer these questions. And then it's going to tell you to change the simulation to light at the bottom of the screen. Answer these. Now, there is one last page, and this last page is used with the light part of the second simulation. It's gonna ask you these questions, and you need to do, answer those. So for that simulation, it's gonna be this one here, and there's like water, there's sound, and there's light. So you'll follow the directions. And what it tells you to, I think you're starting with sound, and one thing that you can do, you got top view, you got side view, you put it on slow, and you press that green button, and it will start a sound wave. You might have to keep on. Like I said, you can stop those. You can change the frequency and stuff. This right here is a tape measure. You can measure, wavelengths with. This is a timing thing, which I don't think we're using. But if you look at this, if you put this in there and put these in there, if you notice, I think you'd only have to have one of them. It's going to show you what the wave looks like. Changed it to kind of a transverse wave there. But anyway, the last part has to go to light. You can change the amplitude to different frequencies of light. Whenever light is at a certain frequency, we see a certain color. Red is the lowest frequency. It's got the less energy. If I, play this, and you can click on this right here, or you can click on this. If I do a side view, it's the same thing. Really, is a top view. Now, when you can pause this, and it might ask you to find the wavelength of these light. Now, there's probably two ways you could do that. You could take your ruler, and you can measure, see where the dark places and the light places. Well, if you measure the distance in between the two light places there, the light ones, you can measure the wavelength of that. All right, now that might not be very accurate. We could do this and, start it, and it gives us a wave. And we can stop it there and then go and try to measure the wavelength here from crest to crest. That would give me 900. I can use that. It might be more accurate than trying to measure within here, measuring in between these points. But you're going to measure these and answer any questions that it has. It might tell you to turn it to the green, and let it go. And you pause it. And again, you can go and measure the distance between. And I don't know where there it went. And you'll see how the nanometers change from different colors of light. And of course, your highest frequency is going to be violet, so your wavelengths are going to be the shortest for that. But that's how you would measure those. Like I said, you can go back, finish answering all these questions. Right, and these are the instructions for how to do this simulation. So make sure you follow all the directions, read everything carefully.